Hello and welcome to another video. This one's going to be about some stuff that I did at work at Sentry and how our Python 3.11 rollout went horribly wrong, but also how I ended up debugging it and finding out what was regressing and went about fixing it, and a pretty decent performance boost after fixing it. But anyway, let's jump into it. You'll notice from this BR that I have tried to roll this out 5 different times. Revert, x10 is revert plus revert. And each time I've run into slightly different problems. The first bunch of them were mostly application issues, but the later ones have been dealing with performance. In particular, there was one Celery worker at Sentry that got significantly worse after rolling out to 3.11. And spiked a bunch of CPU. This is actually like a weird log scale, so this is actually significantly higher than it looks here. Didn't notice that when I was taking the screenshot, but trust that this is actually more like, it's going from 8 to 18, so it's more than doubling. It doesn't really look like that from this graph. And while CPU spiked, this is the region that it was rolled out and then rolled back, the particular queue in question backlogged. It could not keep up with the rate of messages coming in. And so the backlog shot up. We tried to mitigate it by scaling up even further. Several times we have already increased memory and increased CPU on this worker. We've thrown money at the problem and it has not worked. I mean, in theory, if I would have thrown, 4 or 8 times as much money at this problem, it would have fixed it. But that's not why we're here today. We're here to figure out why it got so much slower and why it chewed up so much more CPU. Now, my initial approach to solving this was to use the Sentry product itself to figure out an answer to this question. So I looked at the instrumentation of this particular queue in question. The code's actually not very important. All it does is writes to Redis. It does basically nothing, which is why I was so confused why it could get slower. When I instrumented this with Sentry and then rolled that out to production, I don't have screenshots of this because it wasn't that interesting. It actually looked like it was getting faster, which was perplexing. All of the spans over the relevant portions that I was looking at were a few milliseconds faster than they were in 3.10. And this is kind of what I expected from this. 3.10 to 3.11 should have about a, 10 to 60% CPU improvement for CPU bound code. Now, running to Redis doesn't really run that much pure Python, but there's some pure Python that's run, so it should speed that part up. At least that was the hypothesis. So why, if the task is faster, why is it slower overall? And unfortunately, I couldn't use Sentry to figure this out. I probably could have if I would have dug a little bit further into the profiling tools, but none of the ones were wrapping the actual relevant code that I was interested in. I'll show you the answers that I ended up finding using a tool called pyspy. Pyspy is what's called a sampling profiler for Python. I'm going to go over the difference between a sampling profiler and a deterministic profiler in a different video. You can kind of simplify the idea of a sampling profile as it takes a snapshot of the process in time and looks at what functions are running and uses that to figure out what is slow. Whereas a deterministic profiler traces as it goes, and I guess deterministic is also called a tracing profiler. And so it has a full view of every function call. So this might miss very, very small functions. That's kind of the idea behind this. The nice thing about sampling profilers is they have very little impact on the actual execution of the code. And so you can kind of attach them to a running process without really impacting how it runs. And so what I decided to do is take the current running process, attach pyspy to it, and run it in production and look at it in production. Yeah, a little bit scary. This is something that was done specifically with a SRE buddy to make sure that I was not doing anything shady in production, and we ran and collected some profiles. Now, since we were running in Kubernetes, we needed some additional settings. Notably, pyspy uses ptrace, the same thing as like strace and other stuff, to watch execution. And by default, this is disabled in pods, so you'll get some sort of permission denied error. I don't think this is actually the same error that I got, but I got some OS error 13, which permission denied. But adding this capability to the pods that we were using, which were isolated from the normal production pods, allowed us to run pyspy and look at profiles. Now, if you're not super familiar with Celery, usually the way that you run it in a forking mode is you have a main process and it forks off a bunch of workers below it. We've configured ours, or this particular worker, to have 16 workers below it and one managing process. This makes it a lot harder to profile because you have 17 different processes going on in your container. So we actually adjusted this worker specifically for our experiment to only have a single child process, and that made it a lot easier to identify which is the parent, which is the child, and how to profile it. We also increased the number of times, or the number of tasks it would process before it would restart, so that we didn't have to chase down a bunch of processes. And we collected some profiles. The command that I ran looked something like this: pyspy, I think it's run -p, and then we picked a PID and duration 60. By default, it'll run forever, but I wanted a very specific chunk of time so that I could compare it against another profile. And we actually swapped which PID we were looking at, either looking at the parent process or the child process, because I didn't know going into this what thing was causing this regression. And I also used format raw. This was mostly because I didn't want it to just generate SVGs on the box. I wanted to be able to manipulate the data later. I didn't actually end up manipulating the data, but it was easier to have the raw format in case I needed to. But this is basically the command I ran, or I guess the command that the SRE ran for me. It was very helpful in the process. I would not have been able to do that without that. And I got some profiles. So the first of these are in 3.10. This is the management process. It's not really doing anything too interesting. It's basically, you know, attaching to a queue, pulling for results, and then calling the child. That's kind of what's going on here. The worker process is a little bit more interesting here. You'll see that it has Sentry's background thread. This is kind of its little monitoring thread for doing stuff. And it has the actual Sentry instrumentation in the worker itself. And then you get to the actual work here. This frame right here, this process inker, everything below this is the actual incrementation that's happening in counter 0. This is the application code. Generally, you want your application code to be as big as possible, and you want your other stuff that's going on to be as small as possible. And actually, spoilers, as part of my fix for this, I actually improved these two chunks as well. And unfortunately, the part that I improved isn't an improvement for everyone using Sentry. It's specifically some garbage that we're doing to allow Sentry to run in Sentry without causing Sentry to make Sentry go down by having too much recursion and stuff. But we'll get to that in a second. All right, so those are 3.10 profiles. Wasn't really showing too much here. I was pretty interested in how much overhead this was because I didn't actually know from previously, and so seeing this alone was already pretty eye-opening to just how performance happens in Sentry in production. And then we went to 3.11. I'm actually going to rearrange these so that they are easier to see a comparison between the two. So this is the management process, and you'll see here that I've actually rearranged these. Dang it, I downloaded these out of order. This is the 3.11 one. I know because this is wider in 3.11. That was really the only difference in the management process. This is wider than that one. Didn't really tell me much. I thought this was probably just like problem or functions being rearranged. It might have actually been that this is while it's blocking on the worker processing something, which would actually line up with the processing being slower. But I don't know. This wasn't the important part. The important part comes when we look at the this one's numbered correctly. The difference between the worker processes. So this is 3.10 again, and this is 3.11. You'll notice in 3.11 that the actual work is now just this chunk here, and there's a whole bunch more work going on in the sort of SDK portion of this. Now note the actual SDK portion is this chunk over here. This is the stuff that Sentry does, that our version of Sentry does to avoid recursion. And you'll notice here, it's calling this stack inspect.stack. And this is where we're wasting all of the time in our workers. But the flame graphs made this very obvious. Oh, this, Sentry work here, work here. Oh, what the hell's going on here? So we were able to identify that this was the problem. and was able to figure out the code that was using inspect.stack and improve it. Now, an interesting part about this and why it got so much slower is Python 3.11 adjusted how the stack sort of representation from the inspect module adjusted in Python 3.11. And I actually forgot to open up that issue, so let me open up that really quick. Oh, cpython/python, that's the wrong way. So if we look at inspect.stack here, there is this slow inspect.git module issue, and this is due to some changes in 3.11. 3.11 adjusted some, or added some additional metadata to the things being returned by inspect.stack, and that caused more calls to a function called inspect.git module, which wasn't even getting called in 3.10. And this function itself is very, very slow. For things that it doesn't know about, it iterates through the entirety of sys.modules, which can be really slow if you have lots of dependencies or lots of modules or both. Sentry has both, and so this took a very, very long time, and that's what was chewing up all of the time. Just zoom in on here, you can see these git module calls are what's taking up all of the time here. So what's the fix? Well, the fix is either fix Python, which I've done before, but this one there's a patch that's been trying to fix that for years, down here somewhere, trying to fix that since 2022 and has been unsuccessful in it. So if something's slow, the fastest thing to do is to avoid calling it. So I wrote a little replacement for our use of inspect.stack. You can see here it's looping through the current stack frames, trying to find ones that are potentially recursive, unsafe files. I hate the word safe. Don't use the word safe in code. It's garbage. It should say recursion files or something like that. But anyway, that's a different problem. Instead of using inspect.stack, it can just use the stack frames directly. And so this is how you go through the current set of frames in CPython. You ask for the sys frame, and then you loop on fback, which is the previous frame. And this is the file name. So a lot easier, or pretty easy to do, and avoids this incredibly slow function. And with that, I should be ready to finally roll out Python 3.11. Haven't done it yet, but I'm pretty confident about this one now that I have fixed this performance issue here. But anyway, I wanted to walk you through how I debugged this and how I eventually found the problem, as well as the fix, and used some pretty cool tools along the way. Was pretty happy with pyspy. There was one or two things that I would have done a little bit differently, but I don't know, worked great for what I needed. Was cross-platform as well. Oh, I should mention one other thing. Anthony, why didn't you debug this locally? I did. Unfortunately, locally, it didn't show these particular problems because my suspicion is it didn't show these problems is either there was no Sentry to report to, so it just skipped it, or actually, I think more likely is that no issues were run into, and so it didn't do any Sentry reporting. But yeah, it didn't show it locally. In fact, locally, 3.11 was outperforming 3.10, just like I expected. And so I wasn't seeing these very surprising slowdowns like I was in production. But anyway, hopefully you found this useful. If there are additional things you'd like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.